There's a toxicology.
Yeah, there is a. Okay, so I'm going to start. I want to warn you guys, this is not posted yet. I'll post this later, but I'll do this every now and then on the recording just to give you guys something going down through here. So here's kind of the learning objectives for what we're doing. The other thing, you guys know hearing loss, very serious problem worldwide, and it's the #1 area of workers' compensation. The other thing you need to remember, hearing loss is irreversible. Basically, if you have hearing loss, it's never going to repair itself, and damaging noise levels are basically always easy to access, and it's always avoidable. How's it avoidable? When we talk about hierarchy of controls, what can you always do with noise? Yeah, eliminate it. That's it. Why don't we do it, Dave? Money, money, money. Yeah. Usually it's resources. Guys, I'm a terrible singer too. Now everybody's laughing. Here's another, and I'll post this, kind of the frequency waves. It helps out. I like this. And another wavelength. So, remember the first question we did. Sound pressure level. I'll give you this one. Kind of walks through it, kind of what's going on. Sound intensity. Again, you can see your intensity again may be there. So, here's your question. Dave talked about it, and I wanted this one because he hit it. What's 140 decibels?
Aircraft carrier flight deck.
There you go. Dave said it, an aircraft carrier. What is that 140? Why do most normal people never hear 140? What's that say right there? What will we do when we're exposed to that? Yeah, we'll run away. What about 180? Anybody ever been on a rocket launch pad when they're launching it? Why not? What would they do? Yeah, look at your sound pressure level there and basically look at your decibels as you can see. Again, you can see you guys got to do the noise dosimeters and the sound level meters around 80, noisy restaurant, vacuum cleaner 70, subway on there. So another set. Here's what I showed you earlier. Remember the shortcut I gave you? I want you now to go back to the problem I gave you. What were the problem numbers on that?
89, 92, and 93.
Okay? I want you to use this equation to solve it now. And you're going to have to see that on this, L total is 10 of the log, and you're going to sum up Li, which is each source divided by 10 raised to the 10 power. So you're going to go 10 to 89 divided by 10 is what? 8.9. So you go basically 10 to 8.9. 10 raised to the 8.9 is what? Not 89, but close. You're going to do that. Then you're going to keep going through, and you'll end up getting the same answer you got. But I wanted you guys to see that equation, understand. This is the official, I hate to say why, that what I told you works. And you'll find out they're the same. I gave you anatomy of an ear again, and also here, where does everything cross in 1,000? This is actually hearing loss at different levels. So again, your daily noise dose. This was another calculation that's in your steward book, because we'll talk about 100%, and this is by OSHA. What is the OSHA PEL for noise? Where would you guys go to find that? Yeah, the OSHA, you'd look it up, and you'd find out it was 90 decibels. Does that surprise everybody? The OSHA PEL is 90. What do we always talk about? 85, yeah. Why do we talk about 85 for OSHA? That's the action level. Now, ironically, ACGIH, if you use their booklets, you guys remember the booklets I gave you? Go in and look at their noise section. They've got a section on noise, and it will talk about the 85 decibels, and they have a different action weighting. So I wanted you guys to see this daily noise dose level. And again, here is actually a chart describing what I just talked to you guys about. This is OSHA's noise limit, the PEL, and the need for engineering controls. And you can see as you go down through there some of the reference hours. You will see that in a couple of your calculations this time. You'll actually have to use the reference hours. This is in your book, in your Stewart, but I'll post this PowerPoint so you guys have it. The other thing too, ACGIH limits on it. If you see that, remember 8 hours, ACGIH is 85. That's the difference. So here's a quick calculation for what if you're exposed to, and I want you guys to do it. If I'm exposed to 90 decibels, what is the answer in the number of hours I can be exposed to? So I want you guys to work this. Somebody do it real quick. 8 divided by 2, and you're going to raise it to 90 minus 90 is what? 0. What's 2 raised to the 0, guys? Because you got 0 divided by 0.5 is what? Nope, 0 divided by is 0. Anything divided or multiplied, 0. So you got 2 raised to the 0 power. It's 1, absolutely. So how many hours can I be exposed to? 8 minus 1. Or 8 divided by 1, sorry. 8, yeah. Do you guys see, if I put 90 in there, that's 0. So this is telling me for 8 hours, I can be exposed to 90 decibels. That's OSHA's. You guys got the benefit of actually seeing a sound level meter. You're going to notice you've got all the different parts in there. Benefits of controlling, you guys know this, compliance, employee morale, all those things we already talked about earlier. The other thing, if you control it at the source. In other words, if you can control noise at the source and basically do what we were talking about earlier, surround it and keep the noise from getting out, it'll lower your noise level significantly. Somebody earlier said something about vibration. That will really control the noise if you quit things from vibrating. It was just, you'll see this in your calculations. This is basically your blade noise frequency, sorry about that. And this is actually where you have your RPMs times your number of blades divided by 60. Because again, RPMs, you're taking it from minutes and you want hours. So there's another calculation you're going to see. And my favorite one. So, you guys, I'm on the back of a fire truck. I want you guys to write this down. I have a reading of 100 decibels. 100 decibels, and I am basically 1 meter from the siren. I go by someone on the road. They are 10 meters away from the siren. What do they hear? So again, I'm on the fire truck, 1 meter from the siren. I have 100 decibels. I go by someone on the road. What level do they hear at 10 meters? You should be able to tell me. How are we going to work that? So look at your equation I just put up. What is your sound power level 1? What'd I tell you guys? 1 meter away. 90 decibels, right? Or 100 decibels. Sorry, I'm getting it mixed up. So then I take 20 times log and the distance. So what's D1? What I tell you sound pressure level was? 100 and how many meters? So what is D2? 10. So do the math for me. Take 1 divided by 10. Take the log of it. 0.1 log is? Yep. Negative what? Negative 1. Multiply it by 20. What do you get? 80. So that is the level that person hears as the fire truck goes by. Pretty cool, isn't it?
Now, are pretty much all these all in log based then?
All your noise are log-based, Dave. Definitely.
Right, I mean, just the natural log, we don't have to worry about, log based.
Actually, it's a log of 10. It's not the natural log. So if you use your LN or basically your natural log, it won't work. So good point. I agree with you. You've got to be careful on your calculator. Great point, guys. Okay, so you saw that one. So here's kind of the rules for barriers. How do you actually reduce noise? And again, they've got to be airtight. Basically, interior's got to be the same shape. We also talked about enclosures have got to be dampened. So as you look at it, kind of the noise reduction, you can see I gave you another equation using barriers to reduce noise. This actually takes into the height and the distance from the receiver. And you can see you can calculate, but you've got to know your wavelength, which is the 344 meters per second hertz in your cycles. So again, just another equation. So any questions? That's what we're going to cover on noise. I mean, we've spent a lot of time on noise. You guys have some reading. Anything else you guys want to know about noise? Okay. We're going to do toxicology in about 5 minutes. So you guys